Hi everybody, Patrick here from EngineeringShot.com and ElectronicLessons.com. If you've been watching my videos recently, you'll know that I've been building a lot of kits and placing instructional videos on YouTube. So if you're interested, look back through my channel or visit EngineeringShot.com today. This is a little 555 timer signal generator. Let me just give you a close-up of the final product. This was the first module that I put together myself. It doesn't have the 4-pin header, so I've included it in this shot. And what we're going to do is we're going to put it together and then we're going to do a little demonstration. This kit comes with a custom PCB, a 4-pin header, two 10k ohm resistors, a 10 nanofarad ceramic capacitor labeled 103, a 0.1 microfarad ceramic capacitor labeled 104, a 555 timer, and a 2 mega ohm variable resistor, a 10-turn trim pot. So now we're going to put it together. But before we do, let me just tell you a little bit about the kit. On the header, there are 4 pins that are labeled on the board. VCC, reset, out, and ground. If you ground the RST line, the reset line, the output of the 555 timer will stop. It will stop working. That is, it's an option. You don't have to use it. If you apply power to VCC, say 5 volts to 9 volts, in your DC ground, you'll be able to adjust the frequency of the output between roughly 3.5 Hz and 1.4 kHz. Now when you get up into the range of 1.2 to 1.4 kHz, the duty cycle changes drastically. Really, the most useful frequencies are between 3.5 and 1.2 kHz. So it's a small frequency signal generator circuit. Very easy to put together, very easy to use. I'm going to bring in my oscilloscope after we're done building it, and we're going to test it together. Before we talk about how we're going to place these, I want to talk about CX, RA, and RB. These are timing components that offer us the 3.5 Hz to 1.4 kHz output. You can change these values, these timing capacitor and resistor values, as you see fit. If you'd like, you can change these values to give you a different output range. And if you're curious about that, Google 555 timer calculator. Now remember, this is an astable mode. Astable means it's sending out a square wave. There is another mode for the 555 timer called monostable, and that's a whole other story. This is not set up for monostable, it's set up for astable. So if you want to change those values, look it up online. RA is between pin 8, which is VCC, the 555 timer, and pin 7. RB is between pin 7 and pin 6, the 555 timer, and CX is between pin 6 and ground. So that aside, let me tell you about the other 10k resistor. The other 10k resistor, which is R1, is a pull-up resistor placed between VCC and pin 4 of the 555 timer, and that's the reset line. So that's pulling the reset line high. As soon as you ground the reset pin, it pulls that line low, resetting basically disabling the 555 timer output. Yeah, again, you don't have to use that, but that's your option. So if you ground the RST line, your output stops sending out a signal. The 10 nanofarad capacitor labeled 103, which is placed right here in the C2 footprint, is ceramic as well. And that is between pin 5 of the 555 timer and ground. And that's normally you'd have that capacitor in higher frequency applications, but just for good practice, we've placed it there. However, at this low frequency, it likely won't affect the output of the 555 timer a whole lot. But since it comes with the kit, make sure to place it. Now, since these are resistors and ceramic capacitors, it doesn't matter which way you place them into the footprints. They have no polarity, so solder the capacitor labeled 104, which is the 0.1 microfarad capacitor here, the 10 nanofarad capacitor here, and your two 10Ks here. Now they're labeled on the board, so you shouldn't have too many problems. Solder those into place, and then we'll do the variable resistor. Next, we've got our variable resistor. Very easy. Footprint. The footprint has a knob indicator. There is a knob on the right hand side, so it really doesn't matter too much which way you put it in. If you put it in this way, it'll still work, but you'll be turning different ways for higher and low frequencies. So we'll just place that in, solder it in. I'm also going to talk about the header in this segment. The header has a side with short pins and a side with long pins. Now you don't need to put the header on. You can solder wires directly to the board. But what I like doing is I take the 4-pin header, put it in the header holes, and solder it into place. So let's just do that in one step. Then we'll talk about inserting the 555 timer. You'll notice that the 555 timer footprint has a notch on the left-hand side. Make sure that you match that notch up with the notch on the chip. If you get it backwards, you're going to have to desolder the entire circuit. You might even fry the 555 timer. In all likelihood, you'll fry the 555 timer when you power it up. So make sure that the notch on the chip is placed on top of the notch on the footprint. So place it in, solder it in, we'll do a test. And we're all done. Easy, huh? So now what I'm going to do is I'm going to hook this up to a breadboard and my oscilloscope, and I'm going to show you how it works. I completely forgot to show you this. If you solder the long side of the headers facing down, it's a wonderful little signal breadboard signal generator. Fits right in. So that's actually how we're going to test it. We're going to test it like this. Now I'm going to break out my oscilloscope. So I'm all plugged in. I've got my ground wire grounded to my DC source. I've got 5 volts on the VCC line in red. My output's connected to my oscilloscope. Oscilloscope probe is grounded. And you've got the green wire, which if I ground, the output of the 555 timer will turn off. So let me show you the oscilloscope. Sorry about the haziness, not much I can do about it. It's the refresh rate of the oscilloscope. Anyway, right now what I'm going to do is, first of all, I'll show you the reset. When I ground the reset line, as you can see, the output goes to 0. Every single time I ground it. So that's an option. You don't have to use it. If you leave it floating means unconnected, then nothing happens. So if you turn the variable resistor, the trim pot, right, the frequency goes up. Now that's right at the end of the spectrum. That's when the duty cycle changes. It makes a drastic change. Very, very drastic. So that's the high end. You turn it left, you make the frequency larger. Or smaller, sorry. As you can see, it's starting to slow down until it gets to a certain point where it maxes out, because the resistor is turned all the way to the left. Your resistor will keep turning, but it maxes out when it gets to a certain point when you turn all the way left. So that's your roughly 3.3 hertz. And if I turn it up, it eventually gets to a point where it's about 12 to 14 kilohertz, and then it just becomes unusable, because the duty cycle changes so much. Now this is several turns later. We're in the 8th or 9th turn right about now. It's going to happen anytime soon. It's going to happen soon. There we go. That's when it becomes unusable. It goes from that to that relatively quickly. But that's right at the end of the spectrum, right around the 10th turn. So that's your 555 timer signal generator. Hope you guys liked the demonstration. I enjoyed making it. I hope you visit www.engineeringshot.com and www.electroniclessons.com.